Hey Apes, this is Miss Hubbard. This is chapter 11. We're talking about feeding the world. This chapter is pretty intense, so make sure you take plenty of time to read it and review it. So this is the deal with, we're talking about how we fed ourselves over the millennia. And if you look what's going on here, you're going to look at the global undernutrition. This is the number of undernourished people declined through the 70s and 80s. And we've had the lowest at 800 million in 1996. After that time, it's risen up. So we're going to talk about the reasons for all those things. Humans started around 10,000 years ago just doing hunting and gathering. We did that for a long time until about 10,000 years ago, and then we started doing agriculture. And now we're dependent mostly for our food on agriculture. We still have before we had secure agriculture, a lot of starvation was super common, and nobody got all of the needed requirements for their diet. So luckily, agriculture came along. We developed ways to produce food by planting it and harvesting it. So it helped a lot. Unfortunately, a lot of people are still starving in this world. As many as 24,000 people starve to death each day. 8.8 million people each year starve. In this time of such great, we know so much, we have such technological advances, and we still have so many people dying from starvation. So there's different forms of malnutrition and nutrition. Undernutrition is not getting enough calories. Malnutrition is not getting a particular balance or a particular vitamin or mineral that we need. And overnutrition is what's happening in the United States, where people have too many calories and are not getting the proper foods in the right balance. So that's overnutrition. Here is the per capita meat consumption. If you notice, there's a difference between what the rest of the world eats and what we eat in the United States. We eat quite a bit differently than the rest of the world do. Grain production has increased, and if you look at the total grain production, it's increased over time from the 50s till nowadays, and that's because of many advances in the way we do agriculture. But if you notice the bottom chart showing you that how much grain we produce per person in the world is starting to decline. It's stayed, pretty much the same, and now it's starting to go down a little bit. There's many reasons for undernutrition and malnutrition. The most important one is poverty. When people are poor, they can't purchase the kinds of foods that they need. Another big giant one is political and economic factors. So when governments have wars, when governments don't distribute the food in a proper way, then people don't have access to it, and they cannot buy it. And nowadays, a lot of agricultural resources like grains are, instead of feeding people, they're feeding animals. So, and remember the trophic levels. Every time we go up a trophic level, we're only getting 1/10 of the food energy from it. So that's not a good thing, especially in poor countries, because if you divert the grain to animals, then you've lost you only have 1/10 of the food energy left from that trophic level. So that's a bad thing. The Green Revolution, nowadays we're trying to find better ways to take care of agriculture, using the right kind of fertilization, the right kind of irrigation, and new and genetically modified crop variations that might help us get a better yield of crops. There's two problems when we irrigate. All these advances are great, but and we're irrigating a lot of crops, especially in arid areas like California. Two things that can happen when you irrigate a lot is you can do waterlogging, which can mess with the roots of plants, and then they don't have enough oxygen and they cannot survive. That's called waterlogging. Or salinization, which means that the salts that are in irrigation water are dumped onto the land over and over and over again, and then you get a high concentration of salt, and then the soil cannot support plants anymore. There's too much salt in the soil. That's called salinization. It happens in more arid areas. This is showing you how it happens. So irrigation water has salt in it, and it lands on the soil, and the water evaporates, but the salt stays there, and it gets more and more and more salt in the soil. And waterlogging is just showing you there's tons of water. It's left there, and the poor plants don't have enough oxygen because the water's taken up the area where the oxygen should be, and they can't live. There's two types of fertilizers that we use in ag. One's organic, coming from plants and animals, from either dead plants and animals or the excrement from animals, like manure and stuff like that. Inorganic are made in the factory. They're taking nitrogen from the air and being able to convert it from nitrogen in the air to ammonia and ammonia compounds that we can use. So it's kind of like what lightning does in the nitrogen cycle. We're doing it chemically. One bad problem of the way we do agriculture is we have one giant monocrop of wheat, for example. When you have that, these monocrops are susceptible to more susceptible to diseases because they're a perfect place for a pest that likes wheat to live. There's millions of wheat heads right there. They can just land on anyone, and then they can reproduce, and all that kind of stuff. So monocrops are not good in a lot of ways, especially if you have a pest. And how are we going to get rid of that pest if it loves wheat? There's different types of pesticides. There's ones that are most of these are chemicals that are made in a factory, but there's some pesticides that are natural, like some plants naturally make some chemicals that kill off pests. So there's natural ones, and then there's man-made ones. There's also pesticides that you can kill a lot of different stuff with, and there's ones that only kill one organism. So broad spectrum kills a lot of stuff. Selective kills just a little bit. Kills one or just a few different organisms. Some pesticides are persistent and some are non-persistent. Persistent means they stay in the environment for a long, long time. Like, I don't know if you've heard of DDT, which was a chemical used to kill mosquitoes for malaria control. And then it stays in the food chain for a long time. It goes all the way up to the tertiary consumers, and that's why we had trouble with bald eagles and other birds of prey, because the DDT disrupted the eggshell making of the females, and then we couldn't have any little chicks because the eggs were not formed correctly. So that's called a persistent pesticide. Non-persistent is something that breaks down quickly. Bioaccumulation is what I was just talking about. If you have a persistent pesticide and it stays in the environment for and bioaccumulation means, like, remember how trophic levels, if you had the first level, the next level has 1/10 of the energy. Well, bioaccumulation is the opposite. Once like a mouse eats a grain of wheat that has DDT on it, it has a little bit of the DDT in it. When the eagle eats the mouse, then and eats lots of mice, then there's going to be lots of DDT in the eagle. So that's called bioaccumulation. It's getting more and more in the higher levels of the ecosystem. That's called bioaccumulation. Some pests over time evolve a resistance to that pesticide, so it's no good anymore, so then they have to change to a different pesticide. And a pesticide treadmill is where you have a cycle of pesticide development followed by pest resistance, and then you got to find a new one. So this is kind of like the treadmill people are on, who are in ag science. They're trying to find a new pesticide, and then it goes bad, and they got to find another one. We're trying to use genetic engineering now, GMO kind of foods, where they've been bred to resist different pests. And some people think that's a good thing. Some people think that's a bad thing. because people are worried about genetic modification. They're worried that maybe that's going to hurt us when we eat those things. There's different ways to farm. Conventional farming is using a lot of machinery, and that's the way most of the things are done in Central Valley. There's traditional farming where we have humans and animals plowing the fields, and there's not very much machinery. There's shifting agriculture. That means you plant an area and then you let it go fallow, and then you plant a different area the next year, and then you start, it's called crop rotation also, where you grow in one area, then you leave that area alone for a while, and you go somewhere else and plant a new area, and that keeps the soil from getting depleted from its nutrients. We also have nomadic grazing where like you'll take a bunch of goats, you'll let it graze in one area, and then you'll change to a different pasture in a different season of the year, and then you don't overgraze one particular area. We have areas that we can mess with, and it's called desertification, where we're making deserts, where we're degrading the soil so much that we're changing it from soil into desert by using bad ag practices. So some areas are very vulnerable, like California is pretty vulnerable because we have very low rain in our area. And you can see the bands on there. It makes sense, like in Africa areas in Australia, where the soils just can't take too much ag on it, too much agriculture on it. So these are ways to, sustainable agriculture are ways to keep planting areas from being depleted and from not messing too much with the environment. Intercropping is one where you put two or more crops together, like you put one row of corn, you will put one corn of tomatoes, something like that. That's called intercropping, and it makes it so that the soil doesn't get depleted. Crop rotation is what I talked about before, where you grow crops in one area and then you leave that area alone for the next year, and then you grow crops somewhere else. Agroforestry is where you're putting trees in with vegetables, with plants, so that the trees are going to trap any soil that gets wind blown away. And you can see that a lot when you go to agriculture areas where they have like long rows of trees, especially near the farmhouse, so that the wind doesn't pick up all the dirt and let it go for miles. This would have been especially helpful, like if you guys learned about the Dust Bowl in the 30s in the United States, where people changed from the normal grasslands that were in the plain states, and they decided to change it into wheat fields. And when they did that, they just like screwed up the soil really bad, and they didn't know what they were doing, and they let all that soil blow away. And some of the soil even went to Washington D.C. It went so far, it got blown that far. So people really messed up when they decided to the way they decided to farm the Great Plains and turn it into the Dust Bowl. So you probably learned that about that in history. Contour plowing means, like, if you have a hillside, then you're gonna make lines along the hillside and not down the hillside. If you make rows down the hillside, then all the soil is gonna run down the hill, and that would be bad, and we would lose it. So here's some examples of contour plowing. You can see up here where they're going along the sides of the hill so that soil won't get washed down. If it gets washed down, it's going to set in this area right here and not go all the way down the hill. No-till agriculture, all the stuff you see in the Central Valley is they're using big machinery to till the soil. No-till means they're gonna not break up the soil to bare ground. They're gonna leave some residue from the previous crop on there. Integrated pest management, you need to know for the AP test, because they're going to ask you about this. And these are the things that we've been talking about. How can you minimize using pesticides, and what would be a better way to keep pests from messing with your planting? So all the things that we just talked about are ways of keeping pests away from your plants. Because if you do crop rotation, you're not going to for many years have the same crop in one place, and then you're not going to have bugs decide to live there and stay there for years and years and years and eat up your crops. You're breaking up the whole cycle of pests and their life cycle, and it works a lot better. So all these things are ways to keeping pests from getting out of hand. This is talking about how you can increase your harvest by doing integrated pest management. And there's also organic agriculture, which means you don't use any synthetic pesticides or fertilizer, only natural things that are naturally occurring. And people are liking these kind of vegetables and fruits. So some places we take cattle and we fatten them up, feedlots and things like that. That's called a CAFO, Concentrated Animal Feeding Operation. And it's not a good thing for the environment because look at all the soil, and it's all compacted and all that manure in one place. It's not a good thing for environmentally for that land right there. Now, fisheries, we talked about a little bit of fisheries when we did the let me get to that part of the chapter, when we talked about tragedy of the commons. And we're really messing with our fisheries right now. We're not doing a good job with it. So let me talk about that really quick. So, you know, a fishery is a commercially harvestable population of fish within a particular ecological region. It just means that there's a certain amount of fish that we like in a particular region. Okay. So, this chart is showing you that we're getting less and less fish every time we go fishing. And that's because what we've done is, instead of being really intentional about what kind of fish we want, we've just gone and taken huge nets and gone out there and caught everything in that net, and we don't throw back the fish that we don't want. We just take everything, and the fish we don't care about, we just let them die. So that's called bycatch. And so that's happened, and we've also taken all the fish, no matter what their age is. So we've taken young fish, middle-aged fish, old fish, and we haven't left any fish in there that are still reproductively active, and then we have no new parents to make new fish. So we haven't been doing our fisheries very well. We haven't been fishing very well. So we need to fix that. So what they're thinking is, hey, maybe we can do our catch in a better way. Maybe we can actually put big giant enclosures out in the ocean and harvest and like produce fish that way, where we just put a bunch of salmon out in a big giant net and we let them reproduce, and we leave them there, and we only catch those fish. We don't catch any other fish. So it's like just a big giant enclosure where it's kind of like a little feedlot, like cattle feedlot. Well, we're doing the same thing with salmon. So this is what they do. They make these little enclosures for the fish. They feed them, and then they harvest them and they only harvest the ones that they want. They don't harvest all the little ones. I want you guys to look at this chapter as really take a look at it. It's got a lot in it, so I want you to really focus on it and read it carefully. Maybe take notes on it. It would be really, really helpful because it's got this chapter 11, has a lot in it. Okay. Apes, I'll talk to you later. Bye-bye.